Welcome to Spark Notes, where we unpack the tech shaping tomorrow today. I'm your host, and in this episode, we're heading to Starbase, Texas, SpaceX's launch site, where the world's smallest AI supercomputer just touched down, hand-delivered by Nvidia's Jensen Huang to Elon Musk. The star of the show is Nvidia's brand new DGX Spark, think supercomputer, but shrunk to the size of a piece of origami paper and the thickness of a hardcover book. It weighs about 1.2 kilograms, yet it delivers a full petaflop of AI performance at FP4 precision. That's enough horsepower to run models with up to 200 billion parameters locally. In other words, it's a rocket engine for AI that fits in your bag. This moment has a nice symmetry. 9 years ago, Nvidia rolled out the original DGX-1, betting big on a future built on AI. Today, that bet leaves the data center and lands at SpaceX, right as Starship is gearing up for its 11th test flight. Smallest supercomputer, biggest rocket. Jensen's words, not mine, but the symbolism lands. Let's talk guts. At its core, DGX Spark runs on the Nvidia GB10 Grace Blackwell superchip. That's the brain and brawn delivering up to 1 petaflop of AI performance at FP4. It also packs 128 gigabytes of unified CPU-GPU memory, so your data and model weights live in one big, fast pool. No more bouncing between machines or cloud instances when you're iterating. For connectivity, you've got Nvidia ConnectX networking, plus NVLink C2C offering roughly 5 times PCIe bandwidth, storage, NVMe for speed, and for visuals there's HDMI out, but hardware is only half the story. Spark ships with Nvidia's full AI software stack, frameworks, libraries, pre-trained models, and Nvidia NIM microservices, so you can move from idea to inference fast. A few workflows Nvidia calls out: fine-tuning image generation with models like Flux, one-building vision search and summarization agents with Nvidia Cosmos, and deploying optimized chatbots using the Qwen 3 family. It's not a dev box, it's a launchpad. If you're wondering who needs a portable petaflop, the early delivery list paints a picture. Alama in Palo Alto is using Spark to push the frontier of running large language models locally. NYU's Global Frontier Lab is prototyping algorithms for privacy-sensitive applications, where on-device compute is a feature, not a compromise. Zipline's getting hands-on to keep pushing autonomous delivery. Arizona State University is running robotics simulations and vision models at the edge. And at Refik Anadol's studio, petaflop performance meets generative art. There's also a who's who of hardware partners: Acer, Asus, Dell Technologies, Gigabyte, HP, Lenovo, and MSI, each building out systems that make AI on your desk feel as routine as opening a laptop. The big pattern here, agentic and physical AI, is moving to where ideas happen: labs, studios, field sites, not just the cloud. Zoom back out, and this is part of a bigger shift. We've all felt the gravity of scaling up in AI. Massive clusters, gigawatt-scale data centers, orchestration layers that look like mission control. DGX Spark flips the direction of travel. Scale down with intent. Put meaningful AI power into a compact, unified device. It's not replacing the cloud, it's complementing it. Prototype locally, keep sensitive data on device, shave iteration loops, and reserve the big iron for when you truly need it. And yes, symbolism matters. Jensen, walking past rocket engines to hand off Spark to Elon Musk, is a signal. AI won't just be coded in the cloud, it'll be carried, clustered, and embedded at the edge, on factory floors, in hospitals, in research labs, and yes, in the payload fairings and ground stations of companies like SpaceX. A quick spec recap for the speed listeners. Up to 1 petaflop AI at FP4 on the Nvidia GB10 Grace Blackwell superchip. 128 GB unified CPU-GPU memory for frictionless iteration. Nvidia ConnectX networking and NVLink C2C for high-bandwidth interconnects. NVMe storage, HDMI out. Full Nvidia AI software stack with NIM microservices, ready for tasks like image generation, vision agents with Cosmos, and chatbots on Qwen 3. Availability? DGX Spark goes generally available Wednesday, October 15th, on Nvidia.com and through partners worldwide. What does this enable? 3 quick vignettes. 1. A robotics team can simulate, train, and test vision models fully on-site, cutting the loop between cloud training and lab testing. You iterate where the robot lives. 2. A creative studio can fine-tune a diffusion model locally, with sensitive data sets never leaving the premises, yet still hit interactive speeds. 3. An edge deployment can run multimodal agents that see, summarize, and act in near real time, without a network dependency becoming a single point of failure. When you shrink the form factor without shrinking ambition, you change who gets to build. That's the promise in Spark's name. So, is this the start of a pocket AI era? Likely. We've seen this movie before in computing. Mainframes to minis, desktops to laptops, phones to wearables. Each step didn't kill what came before, it broadened the canvas and multiplied the use cases. A petaflop in your hand won't replace a data center, but it might replace stalled sprints and delayed demos. It might mean more experiments happen, faster. And that's usually where breakthroughs start. I'm your host. Thanks for listening to Spark Notes. If you enjoyed this episode, subscribe to the channel and follow our podcasts. Share them with teammates who love big ideas in small packages. Until next time, happy trails!